welcome to our lovely lunchtime webinar with Nick Bell, Dr. Nick Bell. Sorry, I'd forgotten that I'd known you before the doctorate came along, but now Dr. Nick Bell. He's going to be taking us through a very interesting hour or so. Now there's going to be presentation and then some questions after, so feel free to use the chat or the Q&A to post questions. If we can, we'll stop when you ask, but otherwise we'll come back to them at the end and go through and hopefully answer them. So I've known Nick for quite some time, probably close to a decade, I guess. That's quite a long time. Old colleague here at UE, and has gone on to do some very interesting things with Cardiff Met and his own consultancy. One piece of housekeeping before I hand over to Nick. We are recording, so if you want to go and hear another slide again, then in a week's time when it's up on YouTube and on the IWFM website, you'll be able to grab that there. Just going to check my notes. I've covered everything. I have. So I've hand over to Nick, who's gonna introduce himself, start the talk, etc. All right.
Great, thanks, Richard. I just want to check. Right, I've got control over the screen. So yeah, Dr. Nick Bell. I'll explain what the talk's all about in a moment. We're going to go at a fair speed. I've got a lot to get through. I am going to keep half an hour on the Q&A and chat. If you wanted to send in questions or remarks, I will be monitoring out the corner of my eye. So the purpose of today is to make sure we've got a clear understanding of the designer's professional and legal duties to take the long view when designing buildings. And what I hope you'll be taking away from the talk is some practical actions that you can take back to your own projects or buildings and implement them at whatever stage you're at. I'll introduce myself in a bit. We'll look at some prosecutions and case studies. We'll talk about why sometimes things go wrong. We'll look at what good practice and legal requirements are instead, and end up with some practical takeaways. I'll hopefully end with about 5 minutes or so for any Q&A and for a little bit more IWFM business at the end. So about me, I do lots of talks, or did lots of talks before I retired about CDM. I talk around my PhD. I talk for professional bodies and I've won awards for my work over the years. I'm honorary principal lecturer at Cardiff Met. We got the University of the Year award in 2021. And when I'm not delivering training, I advise clients and architects and other people on building, maintaining, demolishing, everything from large estates to the Palace of Westminster. I write articles and things like BIM. I rewrote the CDM section of the 10th edition of the REBA job book. And the screen's lagging a little bit. It's lagging a lot. It seems to have frozen, Richard. I'm just wondering,
okay.
Oh, there we go. Yeah. So hopefully it's going to be working again. And then they are just some of the clients I've been working with over the last few years. So lots of managing agents in there. So we're going to start looking at a few relevant prosecutions. Some of you may know this case study better than me. One of my clients got a £1.3 million fine a few years ago for their part in killing a woman. The building was built, it was Manda Shopping Centre in Wolverhampton. I'll show you that in a moment. It had a number of wooden elements on the roof, which were very difficult to access for maintenance or inspection. So what happened was the wood rotted. It got hit by a wind. That in the bottom left, you can see the lid of a big wooden housing for a water tank. That got blown off, shunted over the lip of the roof, and it landed on the woman, killing her outside a Starbucks. My client pleaded guilty and got the fine because they accepted they could have done more in highlighting the fact that there were difficult to access parts of the roof. However, if we do a root cause analysis on this and go all the way back, the original designers came up with a building that had wooden components on the roof that's obviously going to rot, and they built the roof in a way that was difficult to access and maintain. And this isn't strictly FME really, but just to show you the magnitude of the fines we can get if we hurt members of the public. This little kiddie was playing football in the car park, wasn't really being naughty, lobbed the football over the railings, went to get it and got electrocuted. £6.5 million fine. So I guess if you are managing buildings, estates, and there is a risk of unauthorised access, this is the kind of fines we can be looking at these days. We're going to move on to look at some case studies and prosecutions around lack of safe access, particularly around working at height. This was a big case study, or all case study, but it was a big case study at the time where an architect got fined for their part in killing somebody. And this is a plant room we're stood in, and that ladder is going up to more plant above our head. You can see there's an opening in the side of the building, and you can see from the height of the rungs, that parapet's about as high as the back of your knee. So a mechanical contractor comes in to do some snagging after handover, is climbing up the ladder, slips and falls over the parapet onto the back of his head and dies. Completely avoidable death. Turning the ladder around, moving it somewhere else, or actually replacing it with a staircase could have prevented a fatality. And quite rightly, the architect got prosecuted. This is a masterstroke of design where if we walk up on the left-hand side, we brain ourselves on the concrete planks. If we walk up on the right-hand side, we get lower and lower and lower as we hang on to the hand railing. The final solution was a set of ship's ladders through a coffin lid onto the roof. We had words with the designers after this had been installed and challenged them by asking them to consider they've got a box of tools, a filter, a spare part of a motor of something on the roof. How do you get it up the stairs? Well, I don't know, it won't fit. Well, that's not a reasonable solution then. And as a client, we learned from this and created a design guide for future projects, requiring that any access onto a roof where we need to do maintenance should be by extension of the stairwell. We're not going to accept ladders in these kind of situations. Just a few more case studies, and these relate to coordination or consideration of M&E services. This is a new air handling plant going on to an existing roof. By the side of it is a Georgian wired fragile skylight. An apprentice fell through, broke his ankle or broke his wrist, but very easily could have sustained or caused life-changing, life-ending injuries. So what we have here is a designer's not taking into account the wider context of the design, just focusing on their plant, not thinking about hazards in the area that people can be exposed to through the life of this building. And also complete failure to consider access to these higher cabinets. These units could have gone side by side. If they had to be double stacked, then let's give people a little solid plate across the steels to stand on. At the moment, they're going to be standing on the steel work, tripping over, puncturing the membrane. So not a practical design for future maintenance. What should be happening instead, this is Bisria BG6, an image from that guidance note. You may not be familiar with it. It would tend to be used on slightly more complex, larger projects. But at REBA Stage 2, and I'll talk about the REBA stages later. REBA is the Royal Institute of British Architects. At REBA Stage 2, this is concept design. We should have a clear understanding of our heating, ventilation, cooling, air conditioning strategy. Based on that, we should understand how much plant space we need. If we do that kind of exercise, then we end up with plant rooms that look like this. This is from the MOD's Defence Functional Standard, which is kind of like an employer's requirement document. If we don't do that homework, we'll instead end up with situations like this, where we had literally inches between pipes and unistrut. We challenged the design and build contractor, D&B contractor. Their initial defense was there's nothing in the building regs, mate, saying that you need to give people reasonable access. Unfortunately, it ended up in arbitration. The client won. It was upsetting and expensive. All of that plant gets stripped out, gets replaced. So from a sustainability point of view, it's just awful. And while it was right that we point our finger at the D&B contractor, again, looking at the root cause of this, we could go all the way back to REBA Stage 2, where there wasn't an adequate analysis about what the actual plant room requirements would be. And then moving, and then also at REBA Stage 2, we should understand what the service riser zones are going to be through the building. Unfortunately, this is the bottom of a very, very large building, 100 meters from end to end. all the rainwater that hits this building is taken internally through siphonic drainage above this electrical switchgear. So we have high volumes of water under high pressure passing through these pipes with very nice joints in them. It's entirely feasible at some point a joint's going to go and water's going to spray over these electrical cabinets. So we've set ourselves up for a catastrophic failure. I sat down with the client's principal designer, who I'll talk about later what they are, principal contractor, and in front of the client, they were arguing over who should have been looking after this design. So it kind of came across to the client like it was Wild West and people were just making up their own minds as they went along where they would put their pipes. If we'd done a proper exercise like this, at REBA Stage 2 concept design, then we should have probably quite early on realized there was a risk of water surfaces passing over electrical switchgear, and we would have changed the design. These are water tanks at the top of a very large building. So somehow simultaneously in the future, we're going to need contractors to hang on to the ladder, reach over, lift up the lid, dip a ladle in to do dip tests for Legionella or to do some of the maintenance tasks. Unless you've got 3 pairs of arms, that's an impossible task. And that further lid is just completely inaccessible from the ladder. And then in the same development, there was this second tank. Theoretically, we could have moved like a tower scaffold up against the side of this tank to get to the lids. But with all of the expansion vessels and pipeworks, that was just an impossibility. So again, we've got designs that are unmaintainable. And the fire stopping, I took this photo not last summer, but the summer before. It's just completely inadequate. To the lay person out there, they may think that little gap underneath the pipe is quite a reasonable space for a fire stopper to get in and put some foam in or something. If you went to a proper fire stopping company, Hilti, Rockwool, there's various others, they would say that's completely inadequate. We need a couple of clear inches of space to get a proper fire stop around it and to get a fire collar around the pipe. What this means is that even the spatial coordination that we're doing, REBA Stage 2, REBA Stage 3, so again, before planning permission, we should have a clear understanding about the elevation of the pipes within these openings. That needs to be considered alongside things like the fire stopping specification to make sure all of this stuff works. If we don't consider these things early on, then when we get to practical completion and our facilities managers have to go back and start retrofitting fire stopping solutions because this is just completely woeful. And this is what fire stopping should look like instead. So why does all of this happen? I'm going to be getting into psychology in a bit, but most architects that I deal with, that you'll be dealing with, are professional, humane individuals. They're not psychopaths. They don't want to hurt people. They don't want to create problems in the future, but still things are going wrong. And I think we can look at both individual and organizational reasons behind this. So individually, they might lack awareness, so of lack of experience, knowledge, training. Therefore, they can't visualize maintenance tasks that their designs are going to generate. Therefore, they can't appreciate the challenges or risks involved in those maintenance tasks. From an organizational perspective, and apologies, I'm just going to read a wall of text here. Facilities management is a bit of a back of house function. It's not making money or providing services for the client. And I think, therefore, it's not at the forefront of the client's minds. I think, therefore, other factors are prioritized, like let's complete our designs on time to allow construction to start. I have to wonder whether we always set realistic time scales and resources for projects. If we don't, then we're not giving people enough time to consider the whole life implications of designs. If we're appointing specialist contractors like those fire stoppers too late, we can't incorporate their requirements into the earlier phases of design, such as the location, positioning of pipework within these openings. And I think that project processes are skewed. Like if you look at a typical template for a project meeting minutes, it's probably asking questions like, is the design progressing on time to allow us to start construction on time? There's probably not that many prompts or questions about are we happy that the access and maintenance strategy is suitably developed for this stage of the design? Are we satisfied that the client's aware of and happy with the residual risks that this design is going to leave them to manage? And then if you look at things like the liquidated and ascertained damages in contracts, people will be punished for things like not completing designs on time to allow completion to start. Well, if that's what the contract is saying, clearly that's what they're going to be focusing on, not the whole life implications of their design. And I'll talk later about how we can overcome some of these challenges. Oh, it's frozen again, Richard. There we go. Well done. We're going into the psychology. So there's something called melioration bias, where we've evolved over tens of thousands of years to survive. Part of the way that we do that is by prioritizing certain immediate consequences over distant and uncertain consequences. So we might see this with teenagers, for example, where if I don't study for my exam, I might fail that exam in some months' time. That's going to seem less relevant psychologically to them than the certain immediate consequences. If I go out with my mates tonight, I'm going to have a really good time. So that's just psychologically will feel much more relevant and important to them, those immediate certain consequences. And then this Rolodex is intended to represent our brains. We pay much more attention to scenarios, to situations, if we can clearly and quickly visualize them in our brains. So the way that these things will affect us is, if we're a designer, if I don't complete my designs on time, I'm going to get into trouble for causing delays to the project. That will feel like a really important consequence. It's certain, you know, I feel it will be certain and it's going to happen immediately, compared to, will somebody have an accident during maintenance? Well, maybe not. It's going to be a long time away if it does happen. And if they do have a problem, will I personally suffer any negative consequences? Well, maybe not. So our brains just won't give that the same kind of attention that we give to those immediate certain consequences. So there are ways of overcoming psychological biases. So if we were working with architects, designers, clients, we might share vivid, realistic stories, such as that Oxford architect's prosecution for that falls from height. And what that does is help people visualize distant, uncertain events, make them feel more immediate and likely. We can do site visits to demonstrate the challenges, risks, and good practices associated with maintenance tasks, helping people to clearly visualize them when they're developing future designs. We can require commitment from designers to post-occupancy evaluations, including a review of maintainability. And what that does is it makes designers think that the consequences of coming up with a poor design will lead to immediate uncertain penalties or uncomfortableness for them. And we can keep a log of challenges and additional whole life costs that a design generates for a project over the whole life. And we can use that to educate clients and architects in the future. Yeah, and so a question from Philip on chat is, this is being recorded, so you can rewatch it later, Philip. So what should happen instead? I'm going to give you a quick overview of UK law on CDM. We've got the Health and Safety at Work Act in the UK. That allows us to introduce any regulations we want to introduce. When we were part of Europe, when a European directive came out, all the countries in Europe would have to incorporate that into our domestic law. One of those European directives was the Temporary and Mobile Construction Site Directive 1992 that we turned into CDM 94. It's changed in 2007 and again in 2015, and that's supported by guidance. Just something for you to be aware of, because of Brexit, we no longer need to comply with European directives. Jacob Rees-Mogg's come up with this retained EU law bill that's currently going through the House of Commons. It will then go through the House of Lords and then get signed off by King Charles. The intention behind this is, on December the 23rd of this year, 4,000 pieces of UK legislation based upon EU directives will be switched off overnight. It's going to cause absolute bedlam unless a minister chooses to retain it or amend it in some way. So it's the default position. If we don't do anything with it, that law will just become irrelevant on the 23rd of December. That includes health and safety law, environmental law, consumer protection law. So this could have a huge impact on, well, on anybody involved in the built environment in some way. So I would really recommend that you keep an eye on that. Yeah, and if you just type into Google EU retained law bill, you're going to see the amount of controversy that it's creating. Anyway, so CDM. We realized quite early on that construction is quite a dangerous process and also quite complicated because there's so many different parties involved. What CDM is doing for us, so that's the Construction Design and Management Regulations 2015. What that's doing for us is identifying the key duty holders involved in a construction project: client, designer, contractor, principal designer, principal contractor. We allocate duties to them and they have to perform those duties in a reasonable manner. What that means is the more risk that a project or a design will present, the more time, cost and effort we need to put into trying to mitigate those risks. For example, if our design was just purely an internal redecoration project, realistically, we wouldn't put that much time into understanding and trying to mitigate the risks because they're quite small. If we were doing a demolition and new build in the centre of London, really complicated project, we would put a lot more time into risk management. The idea behind CDM is to deliver healthy and safe projects from cradle to grave. So we need to think about how we build, install, operate, maintain, adapt and demolish our buildings. And if we don't comply with CDM, we've committed an offence, we can face unlimited fines. We saw how much those fines could be earlier. Magistrates can send us to prison for up to 12 months and the Crown Court for up to 2 years. So I'm going to look at the designer's duties. I'm not going to go through this line by line. I'm just going to pick out 3 key bits that are useful to be aware of. Designers have to be satisfying themselves with clients aware of their duties. They have to identify and manage risks associated by their designs, which we'll look at in a moment. And they have to provide information with their design to allow other people to comply with their duties, which could include, for example, developing access and maintenance strategies as part of the health and safety file. Dipping into risk management in a bit more depth, they have to think about the risks their designs present to the people carrying out or liable to be affected by construction work. So that's contractors now or in the future, people maintaining or cleaning a structure or using a structure designed as a workplace. So in summary, they need to think about buildability, maintainability and usability. To help them to comply, we've got the wording of the law itself. We don't really ever look at that because it's embedded into L153. That's the document on the right. That's the HSE's official guidance to how we comply with CDM. And then on top of that, we've got industry guidance for each of the duty holders named in the regulations. We're going to dip into the designer guidance in just a moment. I'm just going to introduce you to a few other guidance documents that are knocking around. Oh, going super slow, but there's one for workers. So there's serial guidance C686, last updated in 2009, so pretty old, but actually, if you do get your hands on that, it's got some really good principles for how we should go about developing a maintainable design. And then this is the REBA's plan of work. So this is setting out the key work stages that architects would be working to as they're developing their designs, and then we go into construction and maintenance afterwards. I'm going to focus in on the stages 1 and 2. So this is basically feasibility studies and concept design. This is long before we get planning permission. We need to be thinking about project strategies, and we should have a principal designer in place from REBA stage 1 to help us with things like gathering site information and feasibility studies. So those project strategies include things like considering safe occupation and maintenance of our buildings. So sometimes it doesn't happen, but architects, their own professional bodies are saying to them, as part of the concept design, we should be considering how are we going to maintain and access and replace bits of plant on these designs. And then we're going to dip into the industry guidance for designers. These are freely accessible off the website. At the back of these, the designer guidance, there's something called the RAG list, the red, amber and green list. And these are red list items are design features that the HSE really wants us to eliminate wherever we can. We'll look at a couple of examples and then we'll move on to the amber list items, which you can have, but you would need to justify it, and you should try to remove them from the project if you can. So a red list item it should be highlighting specification of fragile roof lights and roofing assemblies instead. And this is an audit I did last year for a managing agent. It was a Cat A refurbishment of an industrial unit. The roof is fragile asbestos and the roof lights needed attention. The designers prepared their spec in December 2021. They only specified the replacement of the roof lights, not the entire roof. So what we have are really energy efficient, strong, robust roof lights surrounded by fragile asbestos. And the third-party principal designer was only appointed in April 22. So what we had therefore were 4 months, say, of designs developing with no one keeping an eye on those designs or the designers. And I'm going to have a look at the risk register entries with you. And what you're going to see here is how the principal designer is basically telling a competent contractor how to do their job. There's no consideration in these risk register entries of risks to future maintenance workers or risk of the asbestos exposure to occupants. And they're not providing any design responses like, why not replace the entire roof? What was the justification for keeping the fragile asbestos roofing material? So this is the entry around the roof, the roof structure. Principal contractor to undertake a fragile roof survey. Well, we know it's fragile, it's asbestos cement. Fall arrest netting to be installed. So they're saying to a competent principal contractor, you've got to stop people falling to their death. They know that, but why are we keeping this fragile asbestos cement? No justification at all. And then when it comes to the asbestos, they're saying essentially to the competent contractor, they've got to carry out asbestos surveys. Well, we know it's asbestos cement. You've got to have a risk assessments, method statements for working on asbestos. They know that, but what if we damage this material in the future? What's the risk to the occupants? Shouldn't we have done something about it now? And actually, you know, over the whole life of the building, replacing the entire roof with a much more energy efficient roof would probably save the occupants, the client, a lot of money. Anyway, I'm going to start ranting if I don't move on. Red list items continue. Design of roof mounted services that require access without provision for safe access. We saw an example earlier with that ship's ladder through the roof, through the coffin lid. I'll show you another example in a moment. And then we'll talk about glazing that cannot be accessed safely. So by pure chance, I was working as a consultant for the architects who were doing the landscape design for these new buildings and the designers for the new buildings themselves. They have been built now. So at an early stage, I met with the landscape designers and I saw it looked absolutely beautiful. There was trees and planting and planters. It was a wonderful landscape design. I then met with the designers for the main buildings. And looking at the concept design, I could see there was going to be a load of plant on the roof. And I said to the designer, how are we going to replace those in the future? Oh, yeah, we'll just bring a crane in to that courtyard area. Okay, I said, during the construction phase, it's easy to get cranes in. The building, the area around it is going to be fairly unrestricted. Once we get into once the building's been built, it gets a lot more complicated. And on this particular site, we had a train line on one side. There was a strip of land, like an easement area away from that train line that we couldn't put bits of plant on. There was this very restricted access into this inner courtyard. So I said to the designer, can we actually get a crane into that courtyard? Don't know. Well, let's go off and get a study done to make sure that, like a tracking study to make sure that that can work. And can the landscape take the imposed loads that that crane would impose on the ground? I don't know. Well, I know it can't because I've spoken to the landscape designer. So we sat down with the designer for the building and the landscape designer, and then they worked together to make sure that we could actually get the crane to where we needed to get it to, and that the ground could take those loads. And that involved getting a specialist crane contractor in nice and early to help these deliberations. And then glazing that cannot be accessed safely. This photo was taken towards the end of the construction phase. 3 years before this, I met with the client, looked at concept design, met with the designers as well, and pointed out there were windows above the canopy. So I said to the designers, how are we going to get to those windows to replace them or clean them? Don't know, Nick. Can we have them internally beaded? Oh no. Can we have them tilt turn? That's outrageous, Nick. I said, okay, fine. I'm not principal designer. I'm not a designer. I'm just advising you and the client, you need to have a functional strategy. So I come back 3 years later, take these photos and say to the designer, what was the strategy? Bloody hell, yeah, we forgot about that. So then they went into panic mode and started coming up with, whatever ideas they could come up with. First of all, they said, can we use a MUP? Mobile elevated work platform. You can see with that central photograph, the ground at the back is about 2 feet of ground at 90 degrees. The photo doesn't do justice to just how steep this site was, 45 degrees slope. There was nowhere to put MUP. And then they said, could we have somebody standing on that canopy? It was fragile, they couldn't. Can we have somebody standing on that canopy with ply sheets? Well, it wasn't designed to take that loads. Can we have somebody standing on the canopy with ply sheets and backdrop down onto the landscaping? The landscaping hadn't been designed to take those loads. In the end, they said to the client, I'm really sorry, client, but if you want to replace a window, you're going to have to remove the canopy first and then replace it afterwards. Like 40K, don't know, a big cost just to replace a window. Then the client was starting to talk about professional indemnity claims. But all of this could and should have been avoided at concept design by coming up with a functional strategy instead. And then and we're on to our amber list items now. So these aren't things that are banned, but things that need to think careful thought about. We'll start by looking at external manholes. So this is out the back of Westfield Shopping Centre in Stratford. What we have is a very busy bus station. Double-decker buses are hitting manhole covers. I'll zoom in on them in a moment, every 1 to 2 minutes. So I'm going to zoom in. So the manhole covers are within that red square. You can see in the incoming lane. You can tell from the tarmac, there's already been some repairs done already. Zooming in again, those central photographs are showing you how the manhole covers are collapsing because of the sheer punishment they're getting from the buses. So there's clearly going to be risks to pedestrians, buses, maintenance workers. I mean, from a maintenance point of view, like what do we have, like maintenance workers popping up and down like lemmings trying to not get run over by buses? I think what's gone on here, going back a slide, there's probably been either inadequate coordination early on between the main kind of infrastructure designer and the bus station designer. If they'd spoken with each other early on, theoretically, we could have had those pipes running under what would eventually become the footpath so that the manhole covers would be in a much safer position. Or probably more likely, those infrastructure routes had already been agreed. What the bus station designer should have done is referred to those plans as they were developing the bus station, and then they could have moved the incoming or outgoing lane up or down the road, which would have the effect of engulfing those manhole covers. They may still be in that same position, but by moving the incoming and outgoing lane, they would have essentially engulfed those manhole covers within the pedestrian footpath, meaning that we haven't got that risk that we're currently having to resolve. In the end, my client could only do another repair. It was just way too complicated to remodel the entire bus station. So we just did a repair, knowing that within 5 years, we're going to have to repair them again. And then another amber list item would be specification of curtain wall systems without provision for tying or raking scaffolding. So here they're just doing a snag. They're just replacing a defective window. Well, first of all, they could have done it internally beaded, meaning we don't need to get at it from the outside. If that wasn't feasible, then they could have potentially selected a cladding system or pre-installed eye bolts, meaning that, or connection points, meaning that we have something to tie our scaffold into. Because they haven't done that, we've had to come up with this great big mega structure to do to get access up the side of the building. Or they could have specified the use of mobile elevated work platforms. But again, that would have considered things like access routes into this area and the ground bearing capacity of that landscaping. Some green list items then would be provision of adequate access around plant rooms. We saw an example earlier where that hadn't been provided, and thoughtful location of mechanical electrical equipment to facilitate access. So green list items are things that the HSE are actively encouraging. So here we would only ever have to get up to these lights to do maintenance. We would never need to get up to the reflectors at the top. Or here we've got uplighters that we could reach through the handrail. We would, so we're reaching the lights from a position of safety. In contrast, here we've got lights immediately above a handrail. So the design and build contractor was challenged about this. Normally we would use a step ladder to change lights, light tubes. Here, if we used a step ladder, we've got a risk of a human being falling to their death, or light tubes falling onto people underneath. That means we're going to have to do all of this job in the evening or at the weekend when people aren't around, and we're going to have to drag a tower scaffold up there because to do the job, because the step ladder is no longer going to be acceptable. So what we have is just completely needlessly, we've created a risk that we needn't have. What they could have done instead is just beefed up the lights from the wall, or beefed up the lights underneath, or done some uplighters to avoid putting the lights in a position of danger. There we go. So here, going back to a big building, it's got a big atrium. One of the positives to take away from this is this image from an access and maintenance strategy where they've used a graphic to illustrate the different types of activities we would need to do to maintain this atrium. Unfortunately, this was only presented to the client once the building had been constructed, which isn't good. We're going to have a look at the MOOP in a bit. So in this image, it looks kind of cute and cozy. Another positive was their floor loading diagrams. So we knew from the designers what loads the floors could take in different areas. This is the MOOP, the mobile elevated work platform that they were using to install the lights. At the top of the atrium is a light bulb. That is a monstrous MOOP. We said to the D&B contractor, how are we going to maintain that after completion? And their response was, oh, it's LED, is going to last for the life of the building, mate. A year and a day after handover, that light bulb pops. The D&B contractor's response was partly to try to blame the client. Oh, we gave you the BIM model, you should have seen it was a problem. Like, really, you're asking the client to troubleshoot your design. When it came to replacing that light bulb, it was a really tricky job. By this point, the doors had been fitted. Also, we were really worried about damaging this very, very expensive floor finish. So this is the smallest MOOP we could get to underneath the light and still reach it. That meant it was at its full maximum capacity. So the guy in black you can see on the left should have been in the basket, but it kept tripping out the safe working load every time he was inside it. So there was this electrician swaying around at the top. All of these ply sheets and the floor protection gets thrown away afterwards. It has to be done out of hours on the weekend when no one's around because of just the risk of falling objects. It was like a whole day and what, $3-4 grand to replace a single light bulb? Not good. And just another green list, and we talked about this example, practical and safe methods of window cleaning, such as from the inside. So just in summary, this is the sort of advice that designers are getting to help them get the design right at concept stage. before planning permission. And some good practice is the use of building information modelling. So this big new building went on to get the 2021 British Construction Industry Award, and it was modelled within BIM. And this is a really useful tool to troubleshoot the design from a buildability and from a maintainability perspective. This is a later iteration of the BIM model, but even at an early stage, we could say to the BIM model, please turn any lights green and blink. And we could drive around it and say, how are we going to maintain that? How are we going to access that? Or you could say that any asset with some sort of maintenance life, and it has to be maintained, the maintenance period may be anything higher than 0. We turn it pink, and we can then drive around and challenge the designers to give us a solution for access and maintenance. If you're really into BIM, you'll be familiar with PAS 1192.6, which is a suite of documents helping us to use the BIM model. PAS 1192.6 is how we can use BIM to highlight health and safety issues. So you could take a model like this and attach hazard symbols to it to highlight where the access and maintenance challenges or activities might be. So it makes it a really, I just find it really useful. So I've mentioned a principal designer a few times. What they should be doing is acting like a facilitator or a critical friend during the design process. So they'll be asking designers questions like, what information do you need to come up with a safe, functional design? Now that you've got that information, crack on with the design, but what do you think are going to be the key risks for the people who are going to be using it, maintaining it, building it? Now that you know what those risks are, what do you think would be reasonable solutions? Generally, designers are competent in their own right. It's when we stick designs together that we get our problems. And we saw that earlier, particularly around the M&E designs or Westfield Shopping Centre with those manhole covers. So what opportunities do you have or need to work together? Are we introducing you into the project with enough time or in the right sequence to get your designs working together? Do we need to have weekly, fortnightly coordination meetings? Now that you are all working together, how does your design impact on your design, impact on your design? What are the risks or challenges that come from those interfaces? Like the landscape design for those big university buildings affecting crane access for the roof mounted plant. So how do we overcome those challenges? And what information will the client or the contractor need from you about your design to carry out their own duties? So, what information would we put into the access maintenance strategy? So one positive from this design was in the health and safety file, we had these different coloured lines around our building showing us how we would access different elements. And a year and a day after handover, a Windows just spontaneously broke. By looking at the health and safety file, there's a cross-reference to the O&M manual where we had a schedule of all of our windows. And the health and safety file said that the landscape had been designed to take the weight of a large MEWP. And we could see from the schedule of windows exactly how big and how heavy that window should be, or how big and heavy it is. So we could order a replacement. The reason why it broke, probably nickel sulfide. There was a study in Australia. I won't go through all the sums with you, but very roughly, for every 58 toughened glass windows that you have in a building, one's going to break every 12 years. So on this, in this image, we've got an elevation where we've got 54, 54, 52, whatever panels. Very roughly, one window is going to spontaneously break every 4 years, which is why the HSE reminds us that we need to have a strategy for accessing, replacing all of our glazing. So I'm just moving on. And so that's the MEWP that we use to replace the window. So what was happening here was the health and safety file then acted as pre-construction information for future maintenance work, which is how it should be used. And then depending on how complicated the building is, that will dictate how much time and effort we put into developing access, maintenance, replacement strategies. So in this particular project, it was, again, this is around concept stage, we're coming up with this strategy. very, very large glazed building, central London, and it had like a donut roof around the top, they called it. It's basically a very large parapet around the roof. And their proposal was to drop abseilers down the side of the building alongside this portable crane system that would lower the replacement glazing. A lot of work went into this strategy. So in the top right, you've got the image of like a little crane that we would put on the top of the parapet, the donut they called it, to bring the main crane and the glazing panel onto the roof. Then you would, that's the main crane they're using. You would put counterweights into the back and then drop that sucker system with the glazing panel down the side of the building alongside the abseilers. And then they came up with another image showing that the crane could get to every single location we would need to get it to in order to replace those glazing panels. So an awful lot of work went into developing this strategy, but the complexity and the size of the building warranted this effort being spent at concept stage. So we went to planning knowing that the client had the ability and willingness to maintain it in the future. And it's quite normal to see mixed maintenance strategies for things like window cleaning. So in the bottom left, we've got somebody with a pole fed system. In the middle, somebody's abseiled off the roof to clean the balcony. And top right, somebody's abseiled off the other side of the building to clean the windows. So, and abseiling, it can be done. Theoretically, cradles are a safer option because you've got handrails around them. But for a building of this size, certainly also considering that you've got these protruding balconies, a cradle system is just not warranted. So abseiling here is completely acceptable and functional as a strategy. But personally, I would have wanted to have seen like davit arm systems. I stole these images from Altus. But you can have movable or fixed davit arm systems that allow abseilers to come down the side of the building, because at the moment they're having to push themselves feet first over the edge, which is not that easy. And also there's a risk of the rope damaging the building damaging the rope. So a davit arm, it costs more money, but is a much safer solution. But yet again, these are the things that the designers should be considering at concept stage. So all of this gets built into the cost plan for the project, and we get planning permission with the planners knowing that there might be these fixed davit arms, rather than us building it, then having to retrofit davit arms, and then the planners saying they're not happy with it because it doesn't look nice. And then this is some good practice where we were doing a roof replacement project, and the access and maintenance strategy health and safety file was presented as a one-page diagram, really, of focusing on the top right first of all. Now this is an early iteration, so it isn't perfect, but what the designers were doing is using different coloured lines at concept stage to highlight the different types of maintenance activities that would be done. In the end, things evolved. So we've got these lantern lights. They were initially saying they would be cleaned using a mute. That's, you know, off the ground. That's not practical. But instead, the solution was like having people with Ghostbuster packs on the back where they could use vacuum cleaners to suck out the gutters and pole-fed cleaners to clean the lantern lights. And then again, around concept stage, we began work on a plant replacement strategy, which included understanding where a crane would go. And this is an early version of the plant replacement strategy, but this is the designers working with other specialists to understand what components would need to be removed from our buildings and what the strategy would be and how often we would have to do that. So just going back to a couple of images, what that meant was that we had a single page graphic health and safety file, which is so much better than reams and reams and reams and reams of very generic information. So that's really good. So I'm going to move on. So we're going to be wrapping up. There's going to be a bit of a wall of text here, but I've got a question from Nick Fox. Nick, whose scope of work should include maintenance strategies, do you think? I'll come on to that because I think that might be partly answered by some of these points coming up. So if you're involved from inception, sorry, let me go back a slide. If you're involved from inception, some of you won't be, some of you will be, but I would want to include maintainability as part of the selection criteria for the project team. So when we're going off and selecting, for example, consultants, we could get feedback from clients or FM teams on their past projects, get minutes or post-occupancy evaluations. So A, are they actually having these evaluations? And B, are there lots and lots of issues or good practices from their past projects? We can ask them for sample strategies for access maintenance, plant replacement strategies, and we can even look at things like the design risk registers. We saw an example earlier where they weren't considering the whole life risks of a design. It would be great if we, as clients, we could see our operations and maintenance team as a key stakeholder. Usually I see it's the people who are going to be actually using the building day to day as the key stakeholder, but if they treated the FM team as key stakeholder, I think that would ease out a lot of these problems because we could build their requirements into the scope of the project. We talked about the benefits of using BIM earlier. We could specify in contracts that construction can only start if maintenance strategies have been agreed. What we don't want to do is start building something and then to find that we have to completely remodel something in order to make it maintainable. I'm not quite sure how we would do it, but it would be interesting if we could set up contracts so liquidated ascertained damages could be imposed if maintenance costs or plant downtime exceed the agreed figures, because I think that would really focus everybody's attention on the whole life implications, not just getting the design finished on time to allow us to start building on time to allow us to complete on time. And we can include maintainability as a core element of the client brief, which we'll look at in a moment. So if you are involved in the design, there's a little bit of words missing, but we could contribute to maintainability reviews during the design process so that we, the relevant stages in the project, we sit down with the designers to make sure that we're happy with what's being developed. As partners, so a client has a legal duty to check that the principal designer is managing their phase of the project. And that's often not done. But what we should be doing monthly or whatever, sitting down with the PD and asking them from a CDM perspective, how are things going? As part of that, we could ask to review the developing access and maintenance strategy and plant replacement strategies and the early iterations for the health and safety file. So we don't just leave this stuff to the end. We should be keeping an eye on this all the way through the design process. And we could be asking to look at the design risk register. We could require costing of maintenance strategies so that we can actually put a figure to what the strategy is going to be. And we can require a commitment to post-occupancy evaluations for reasons that we looked at earlier in terms of making sure that people understand that they are going to be measured based upon how usable and maintainable their designs are. And then if we're inheriting a building, now I think this is stuff that most of you as FM people will be really familiar with, but going back to that case study with that the shopping centre, shopping centre in Wolverhampton, when we first inherit a building, we need to do a full review of it, including identifying all assets that require maintenance. We'd need to develop maintenance plans if we didn't have some already from the designers or the client. We would need to assess the risks and costs associated with those activities. If, again, thinking about that Manda shopping centre, if we have got hard to reach areas, I think we should be considering using drones to get to them, not just ignoring them. I think it would be really interesting and helpful to keep records of additional costs that are resulting from poor design decisions. And that allows us to then educate clients and designers in the future. And and developing lessons learned can be really powerful tools for the clients or for future projects. And obviously participate in any post-occupancy evaluations with designers and the principal contractor and the principal designer. So that's it. I was quite quick.
So you've done a good job there, Nick, getting us through all of those slides in a reasonable time. Whilst people are thinking of some questions, I've got something that it's worth mentioning. We've started looking at vulnerability as well as maintainability. So of course you've got manufacturer's guidance of say 15 years maintenance. However, because you're coastal, or something, you could take another 5 years off of that, and the vulnerability of the asset may affect its maintainability, and that's worth considering early as well. And that could
Absolutely, yeah.
you may need to think about protecting assets more to prolong their life, etc. in certain environments. So I wonder what your thoughts were on that.
No, I think that's perfectly sensible. And again, if we think about the BIM model and the COBE data, what we've done in the past, Richard, is actually put maintenance frequencies against different assets, where we could certainly take those kind of issues on board. And the other thing that popped into my mind as you were speaking there is also thinking about the availability of components over the whole life as well, because it could be that we get a value engineer a design. We're offered a cheaper motor, but it's cheaper because it's at the end of its production run, and it's going to be really difficult to access spare components later. So actually, do we need to actually hold spares on site of key it might be key components of that bit of plant or that motor, keep the spares somewhere on the off chance that it becomes unavailable in the future.
And you might be able to work out your critical spares supply before you've even started building it. And you could see that you're going to have to hold 50, 60,000 pounds worth of stock because there's a chance that this thing won't be available in the future. It's interesting.
Yeah. And Lucy is saying, thank you for the for a great session, but I feel it should be for the architects and designers more than the FM people. No, I absolutely get that. But what I want or hope that you've got from here is some practical case studies. If you probably got them already, but if you were going to be involved with clients, designers, early doors, the kind of examples that you could be sharing with them. And also, if you are finding that you're inheriting buildings where you have got maintainability issues, and you potentially find yourselves in contractual arguments with people, then you've got a whole load of data here around things like the HSE's expectations, REBA's expectations. And if you are being given designs that aren't maintainable or aren't safe to maintain, then you can, hopefully you're equipped now with material that you can go back and challenge them with, I hope.
I've got a couple of future slides here to run through, Nick. So
yeah, sure.
If another question comes in, we'll jump back on it. This is the slide that a lot of people are going to want. There's a number here for CPD for those that need to rack up the hours. 6640930. So hopefully those that need it can grab that. Now, Nick's kindly put the slides together, but IWFM have kind of hosted this. Just to mention, membership exists, and there are lots of positives and for being a member of IWFM, and all of the regions putting on events, etc. Brilliant networking opportunities and things. There are some upcoming courses that may be of interest to those out there. NEC4, managing building services, all really interesting stuff. And there's some deadlines for signing coming up very soon. So hit the website, have a look. There might be some more interesting things, and they're not all run by Nick. There are other talkers, etc. But worth having a gander at those. The reason I mentioned the Insight Hub is because there's all sorts of brilliant resources on the IWFM website for people to have a look at, and I believe this is where the recording's going once it's all been edited and checked, etc. So that's where that's going to go, so people can go and grab that and share with colleagues that weren't able to make today. Every Wednesday there's another talk. Again, more webinars. We're doing quite a lot of this content for you guys to be able to do over a lunchtime and eat your sandwiches, etc. with. So it's all positive stuff. Thank you, Nick. Thank you everyone else for coming. We have just hit time, so wow, we did well. It's like we rehearsed it. Right, so cheerio everyone, and thank you, Nick.